1 minute ago, Italy raised Campi Flegrei's alert status after ground deformation spiked to 2 centimeters per month, and a new AI study confirmed the region is firing off the same earthquake precursors seen before past disasters. Scientists say the warning signals are active now, but officials insist the risk remains medium to low, even as earthquake swarms rattle 500,000 people living in the red zone. Are we witnessing the final warning before a major event? Or is something crucial being missed? The official bulletin begins with a single line. Due to this series of natural phenomena, since 2012, the alert level of Campi Flegrei has changed to yellow. The words appear routine, almost bureaucratic, but the implications ripple through every layer of life around Naples. Yellow is not a color of calm. In Italy's Civil Protection Code, it means increased unrest, heightened surveillance, more frequent advisories, and an entire region on edge. The April 2025 update from the Istituto Nazionale di Geofisica e Volcanologia confirms the status. The ground has risen by over 1.4 meters since 2005, with deformation accelerating to up to 2 centimeters per month in the Solfatara Pozzuoli zone. The bulletin lists recent earthquakes. May 20th, a magnitude 4.4 at a depth of 2.6 kilometers, and March 13th, a magnitude 4.6, each event stacking pressure beneath a city of 500,000. Yet the language remains measured, even as the earth refuses to settle. Behind the scenes, rumors circulate about a new dark yellow phase, an unofficial category designed to avoid the legal and logistical chaos of an orange alert. But in the official record, yellow stands. No evacuation triggered, no full-scale drills mandated. The alert system is clear on paper. Green for normal, yellow for unrest, orange for pre-eruptive, red for imminent eruption. In reality, the line between action and inaction is drawn with careful phrasing and cautious updates. For residents, every word in the bulletin is a signal. Whether to keep bags packed, whether to trust the silence between tremors, whether to believe that yellow is enough. A new study published in September 2025 by a Stanford-led team working with Italian researchers has brought renewed attention to Campi Flegrei's restless ground. The team harnessed artificial intelligence to re-examine years of seismic data collected from an array of sensors across the caldera. Their findings upended long-held assumptions about the volcano's recent behavior. Where traditional monitoring had counted roughly 12,000 earthquakes between 2022 and early 2025, the artificial intelligence system revealed 54,000 events, more than 4 times as many, with nearly 3/4 previously missed because their signals were too faint. This digital reanalysis did more than add numbers to the catalog. It exposed a hidden world of microquakes, each one a tiny fracture, a subtle movement, a sign of strain building beneath the surface. The model was trained on both local and international datasets and could pick out even the smallest tremors, mapping their locations with unprecedented precision. As a result, the seismic landscape of Campi Flegrei now appears far more active and interconnected than previously shown. Researchers could trace the outline of major faults converging beneath the densely populated town of Pozzuoli. These discoveries have forced a reconsideration of the region's hazard models. The study's lead author, Professor William Ellsworth, called the breakthrough a turning point. Now we are seeing for the first time the geologic structures that are responsible. With this richer seismic record, scientists are able to identify patterns and connections that were invisible before, offering a new lens through which to understand the volcano's restless state. In the heart of the caldera, the ground itself is restless. The Istituto Nazionale di Geofisica e Volcanologia April Bulletin spells out the new reality in precise numbers. GPS and satellite radar data show the uplift in the Solfatara Pozzuoli area has accelerated. What was once 1.5 centimeters per month has now reached 2 centimeters per month. This is not a subtle change. Over the past 2 decades, the land here has risen by more than 1.4 meters, but the current pace is the fastest measured since the Brady seismic crises of the 1980s. Each month the surface pushes upward, forcing roads to buckle and foundations to strain. INGV's instruments scattered across the urban sprawl and volcanic fields log these movements with millimeters accuracy. Satellite INSAR images, updated weekly, confirm the trend. A broad dome of uplift, centered beneath Pozzuoli, spreading outward in a slow-motion wave. Scientists track these shifts obsessively, knowing that such acceleration is rarely benign. In volcanic systems like Campi Flegrei, a jump from 1.5 to 2 centimeters per month is more than a statistic. It is a signal that pressure is building below. The rate of deformation now rivals the lead-up to the 1982 to 1984 crisis, when tens of thousands were forced from their homes. Each uptick in the numbers is relayed in the official bulletins, but the language remains clinical. In reality, the land is moving faster than at any point in the last 40 years. For those who live above the swelling caldera, every centimeter is a reminder. The volcano is not sleeping. It is shifting beneath their feet, and the pace is picking up. A Stanford-led study published in September 2025 set out to answer a question that has haunted Campi Flegrei for decades. Is there a reliable way to know when a major earthquake is about to strike? By analyzing 20 separate seismic sequences recorded between 2015 and 2024, researchers found a pattern that holds across every significant event in their catalog. The study's central finding is simple in principle but powerful in practice. Before the largest quakes, 2 signals always rise together: ground deformation and accumulated seismic energy from microquakes. Not just one or the other, but both in tandem. The preparatory phase, as defined by the team, begins with a measurable uptick in the rate of land uplift, tracked by GPS and satellite radar, paired with a simultaneous surge in the total energy released by small, shallow quakes. This dual signal rule stood out even in the most complex and noisy periods of unrest. For each of the 20 earthquake sequences, the researchers charted the daily deformation rate and the cumulative seismic energy. When both curves spiked, a strong earthquake followed within days or weeks. If only one signal increased, the system often calmed without incident. This dual precursor framework now gives scientists and emergency planners a concrete diagnostic. Watch for both rapid ground rise and a clustering of microquakes, not just one or the other. The study's authors caution that the rule does not predict exact timing or magnitude, but it does offer a clear threshold for heightened vigilance. In effect, the volcano's unrest is no longer a mystery of isolated numbers. When the ground lifts faster and the earth crackles with thousands of tiny quakes, the system is entering its most dangerous phase. This preparatory phase rule is now the lens through which the latest data from Campi Flegrei is interpreted, shaping how risk is assessed on a daily basis. Every morning for the past 4 weeks, the ground beneath Pozzuoli has trembled. The swarm began quietly, just a handful of microquakes, too faint for most to feel, but impossible to miss on the seismographs. By the end of the first week, the pattern was clear. Not a single day without recorded earthquakes, some days counting dozens of small shocks, all clustered at depths between 1 and 3 kilometers. The rhythm has been relentless. May 22nd, 18 quakes before dawn. May 25th, a midday sequence rattling shop windows and setting off car alarms. June 2nd, a shallow event strong enough to jolt families from their beds, followed by a series of aftershocks that lasted until sunrise. The INGV daily logs stack up like a diary of unrest. Hundreds of events, each one a tiny fracture, a signal of stress moving through the caldera crust. Most are less than magnitude 2, but their concentration and persistence are what matter. Maps of the swarm show a dense cluster under the Solfatara crater and the city's historic center, matching the zones of fastest ground uplift. Scientists tracking the preparatory phase now see a textbook case. The swarm is not a single burst, but a sustained, escalating sequence. Residents have adapted to the constant shaking. Children learn to recognize the difference between a passing truck and a real earthquake. Shopkeepers keep inventory low on high shelves. Social media fills with reports asking, "Did you feel that one?" as the swarm continues, day after day. For geophysicists, this 4-week streak stands out not just for its length, but for its alignment with the warning pattern identified in the latest studies. The system is behaving exactly as the data predicted. A continuous swarm, shallow and clustered, running parallel to the accelerating ground deformation. The timing, the location, the daily drumbeat, all fit the rule. This is the window when a larger earthquake, or something more, could be triggered. Deep beneath the city of Pozzuoli, seismic maps now reveal a structure that was invisible to scientists just a few years ago. Artificial intelligence, fed with years of continuous seismic recordings, has traced a new fault, one that does not belong to the shifting plates of the Earth, but to the restless machinery of the volcano itself. This is not a simple crack. It is a ring-shaped fault, several kilometers long, encircling the zone of maximum ground uplift. Its path follows the outlines of the daily earthquake swarms, threading directly beneath neighborhoods, schools, and the waterfront. Unlike tectonic faults, which form from the grinding of continents, this fault is the result of volcanic forces, pressure from below, gas and heat pushing upward, stretching and fracturing the brittle caprock that seals the magma chamber. Each microquake is a signal of stress, a slip along this growing fracture. The AI model, trained to detect even the faintest tremors, has mapped not only the main ring, but also 2 nearly parallel faults converging under the heart of the city. The convergence zone is where the ground is rising fastest and where the risk of a major rupture is highest. Seismic tomography and relocated earthquake data show that most of these events cluster at depths of 1 to 4 kilometers, tracking the boundary between the swelling magma and the overlying rock. The geometry of the faults, long, shallow, and curved, means they act as weak points in the volcanic lid. Every earthquake, no matter how small, chips away at the strength of this barrier. Engineers and geophysicists warn that as the caprock weakens, the chance of a magnitude 5 earthquake grows. The rupture area, based on the mapped faults, is large enough to generate shaking well above National Building Code thresholds, especially in districts built on soft sediments. What was once a buried mystery is now a mapped threat. The ground is not just rising, it is splitting, ringed by a fault that is both a symptom and a mechanism of the volcano's unrest. The caprock, once thought to be a solid shield, is now laced with fractures, its integrity tested by every new tremor. Engineers studying the caldera's urban sprawl have run the numbers. A magnitude 5 earthquake, centered beneath Pozzuoli or the Solfatara uplift, would bring down thousands of buildings in minutes. Their models draw on building inventories, soil maps, and the mapped ring fault, each variable stacking risk on top of risk. The greatest danger lies in the dense neighborhoods built before modern codes, where brick and unreinforced concrete dominate. In these zones, collapse rates could reach 15%, with entire blocks at risk of pancaking under the force of even moderate shaking. The confidential simulations, prepared for Naples City Council and quietly circulated among civil engineers, reveal a casualty footprint that stretches far beyond the epicenter. More than 500,000 people live within the official red zone, an area now recognized as the epicenter of both ground deformation and seismic hazard. Here, every family has a mental map of the nearest shelter. Every parent knows which walls are safest to stand beneath. Community leaders, faced with the numbers, speak plainly. We are living on borrowed time. We know our buildings won't hold. The threat is not abstract. In the event of a magnitude 5 quake, the damage would not stop at cracked plaster or fallen cornices. Thousands of homes could be lost in a single morning, with the strongest shaking hitting precisely where the population is densest. For the 500,000 residents of the red zone, the risk is measured not just in statistics, but in the daily calculus of safety. Whether to stay, whether to send children to school, whether to trust that today's tremor will not be the one that brings the ceiling down. Civil protection officials have quietly rewritten the rules of response. In the spring of 2025, a new color phase, unofficially called dark yellow, was inserted between yellow and orange on internal planning documents. This new tier does not exist in any official decree or public bulletin, but its purpose is clear. Avoid the legal and logistical trigger of an orange alert, which would require immediate evacuation drills and disrupt every aspect of life in the red zone. The decision came after weeks of debate behind closed doors, with engineers and local administrators arguing over the consequences of raising the alarm. The stakes are enormous. Orange means mandatory evacuation planning for over 500,000 people, school closures, business shutdowns, and the specter of panic rippling through Naples' economy. By inventing dark yellow, officials keep the machinery of daily life running, even as ground deformation and earthquake swarms meet the criteria for escalation. At the same time, emergency exercises have been rebranded. What used to be called seismic drills are now officially labeled volcanic eruption drills, with new scenarios involving maritime evacuations across the Bay of Naples to Sicily. Ferry manifests are checked, port authorities coordinate with the Navy, and evacuation maps are redrawn to account for a mass exodus by sea. The language may be bureaucratic, but the intent is unmistakable. Acknowledge the threat without admitting to the public that the threshold for action has already been crossed. For the residents of Pozzuoli and the surrounding towns, the color on the official chart may not have changed, but the rules and the risks have. The burden of decision now rests on the phrasing of a single line in a policy memo, and the consequences of delay grow with every tremor. Official statements continue to frame the danger in cautious, almost reassuring terms. In a September press conference, Fabrizio Curcio, head of Italy's Civil Protection Department, said the probability of an eruption remains at medium to low levels based on current scientific models and monitoring data. This language appears in every bulletin, every televised briefing, and every press release, even as the ground beneath Pozzuoli rises faster than at any point in 40 years, and the earthquake tally climbs by the hundreds each week. The message is always the same: heightened vigilance, but no cause for alarm. Scientists, meanwhile, are issuing warnings that carry a very different weight. Giuseppe De Natale, senior volcanologist at INGF, told La Repubblica in October that the risk of a sudden steam blast eruption is substantial, adding that events could occur any day given the elevated hydrothermal pressure and cumulative seismic energy observed. Peer-reviewed studies published this fall echo that view, pointing to the same combination of accelerating uplift and relentless microquakes that preceded the eruption of 1538. One research team concluded that given the ongoing ground uplift and the clustering of shallow seismicity, the probability of a phreatic explosion is high in the current phase. This is not a technical disagreement over numbers. It is a fundamental split in the way risk is communicated, and WHO gets to decide when the threshold for action has been crossed. Officials cite historical precedent and the dangers of false alarms. Scientists point to the mounting evidence that the system is entering a preparatory stage, where a major event could be triggered by forces already in motion. For the 500,000 residents living above the swelling caldera, the gap between these two positions is more than academic. It is a call for transparency, for real-time access to data, and for decisions grounded in the reality unfolding beneath their feet. Today, 500,000 people live atop Europe's most restless caldera, as seismic alarms intensify and official assurances lag behind scientific warnings. Every tremor adds risk. Every delay narrows the margin for safety. Campi Flegrei's unrest is not just geological. It is a test of collective responsibility. In the shadow of uncertainty, inaction has consequences measured not in warnings, but in lives.